Assume that a sample is used to estimate a population proportion p. Find the 80% confidence interval for a sample of size 391 with 168 successes. Enter your answer as a trilinear inequality using decimals, not percents, accurate to 3 decimal places. Answers should be obtained without any preliminary rounding. However, the critical value may be rounded to 3 decimal places. Okay, so to work this out, the first option we have is to use the calculator exclusively. And the calculator has some very nice functions to do confidence intervals for us. In this case, we would be using the function 1propzint. And 1propzint will come up with a confidence interval. That's what the int means. It's under the stat menu, and you come over here to tests, and you got to scroll down a bit to get to it. But it will calculate a confidence interval based off of a proportion, which is what we're talking about here with percentages of things. Now, what it needs are 3 basic pieces of information. It needs a sample size, n, that's the second thing, so that's usually pretty easy to see, 391. It needs the level of confidence that you want to use, so it says find the 80% confidence interval, so that would be 0.8. And x. X is the number of items that favor your event, so the number of successes that occur here. So 168 is the number of successes in this sample. Now, once you have that, calculator takes care of everything for you, and it comes up with your confidence interval, which is 0.398, and the other endpoint is 0.462. Okay, but it did say to express the answer as a trilinear inequality. Oops, I meant for that to be a highlighter. So as a trilinear inequality using decimals, we have the decimals and not percents. And the way we write it as a trilinear inequality is 0.398 is less than p is less than 0.462. So what we're saying is the population parameter p, so the true proportion of this, what's being studied here, is somewhere between 39.8% and 46.2%. So that right there, that's your final answer if you're allowed to use the calculator that much. If you're not, if you need to use some formulas, then let me show you how to do this with formulas. So a confidence interval, the way we get it through formulas is we need to take our point estimate, p hat, plus or minus some margin of error. So p hat is relatively easy to come up with. P hat is just equal to x divided by n. So in this case, we have 168 successes, and we had 391 items in the sample. So we just divide those, and it's actually listed on the output screen here of 1propzint, but we take 168 divided by 391, and that's how we come up with it. So I'll put it as 0.43. I think that'll be fine. Now, the margin of error. The margin of error is 2 separate calculations. We need to get a critical value based off of our level of confidence and multiply that by the square root of p hat times q hat all over n. So these values we know already because if p and q are always complements to each other, so if you have p hat, you can get q hat by just taking its complement. So 1 minus 0.43 would be 0.57. And we know n as well. But z sub c, what we have to do there is we have to use a formula. It's the absolute value of the inverse norm of 1 minus a given level of confidence divided by 2. So if I take my level of confidence, which was given as 80%, so if I take 1 minus 0.8 divided by 2, that's 0.1 is what this part right here on the inside is. Now I need to do inverse norm of that value. So inverse norm, second in distributions, or second in vars, gives you the distributions menu. The area to the left we just found was 0.1. Now if you're not seeing this menu here, that's fine. Just type in 0.1 and press enter. It'll give you the answer. But if you are, make sure the mean is 0 and standard deviation is 1 so that you're on a standard normal distribution. Press enter a couple of times and you'll come up with, we'll say 1.28 because it did say to take the absolute value of that. All right, so our margin of error then is 1.28 times the square root of 0.43 times 0.57 divided by n, which is 391. All right, so let's see what this comes out to. So 1.28 times the square root of 0.43 times 0.57 divided by 391. That gives me 0.032. Now, if I take my point estimate, p hat, what was that? That was 0.43. If I subtract 0.032 from that, I get 0.398, the lower end point of my confidence interval. And if I take 0.43 plus 0.032, that gives me the upper end point of my confidence interval. So either way, you will arrive at this confidence interval here, but just make sure you answer in the correct form.